All right, welcome. We're going to jump right in and break down the essential steps for designing modern healthcare software. My goal here is to get you prepped for pretty much any exam question that comes your way on this topic. Okay, so here's our game plan for today. We're going to start with the most important part, the human story behind it all. Then we'll get into creating a blueprint, learn the special language these systems use to talk to each other, and then we'll wrap it all up with a summary that's going to be, trust me, absolutely crucial for your exam prep. So, step one. Before you even think about writing a single line of code, every great project has to start by answering one simple question. Why are we even building this? And in healthcare, that answer isn't about, cool features or making money. It's about people. It's about improving their lives. And hey, this isn't just some abstract idea. Just look at these numbers. This is from something called Project Esther. They focused on one simple thing, making the patient's experience better. And the result? Well, they took the wait time to see a neurologist from a staggering 85 days all the way down to just 14. That's a massive drop, almost 85%. That is the power of starting with a clear, human-centered purpose. So you've got to be asking, how is that even possible, right? How can software design have such a huge, real-world impact? Well, the answer starts with a really simple, totally non-technical process. Okay, so once you've nailed down your why, you've got to have a blueprint for the what. And that brings us right to step two, creating what we call the conceptual model. Now, when we say model in engineering, don't think of the final product. It's much more like an architect's blueprint, right? It's a simplified description that just captures the stuff that's actually relevant. It basically lays out the language and the rules we're going to use to build our solution. So to build that blueprint, we start by defining use cases. And look, that's just a fancy term for a specific job the system needs to do. For instance, a doctor needs to schedule a new patient appointment. Super simple. The key here is that it's a story anyone can get, not just the tech folks. And, of course, every single one of those use cases has an actor. That's the person or the system that's actually interacting with our software to get that job done. So, this could be a doctor, a patient, or heck, even another piece of hospital software. Right, so to get the full picture, we take these actors and use cases and we flesh them out across 5 different kinds of models. We've got to understand how the hospital actually works, how the information gets processed technically, who's in charge of what, how the data is structured, and then the step-by-step flow of tasks. Each of these models adds another really essential layer to our blueprint. Okay, so now you've got this brilliant blueprint. But think about it, a blueprint for a new skyscraper is pretty useless if it can't connect to the city's power grid, right? In the software world, this is the massive challenge of interoperability. How do you make your system talk to all the other systems out there? At the very bottom layer, you've got what's called technical interoperability. All this means is getting the data from point A to point B. It's basically the digital postal service. It delivers the letter, but it has zero idea what the letter says. For that data to actually be useful, both systems need to be speaking the same language. And for decades, that shared language, that lingua franca of healthcare, has been HL7, which stands for Health Level 7. Think of it like this. A hospital's internal system might have its own weird dialect, but when it needs to talk to another system, it translates its message into the standard HL7 wire format. That way, everybody's on the same page. And this whole thing follows a really standard development path. You always start with the high-level why and what. That's your conceptual design. From there, you get more detailed with an implementable design, which finally gets turned into the actual software code. This structured approach is absolutely key, especially for these complex systems. Now, HL7 has been an absolute workhorse for decades. Really powerful. But the modern internet kind of changed the game. It demanded something way more flexible. The whole world moved to web APIs, and healthcare data, well, it had to catch up. And this is exactly where FHIR comes into the picture. Okay, so FHIR is built on this idea you literally use every single day. It's called REST. It's the engine that makes the web work. So instead of these big, complicated, rigid messages, REST thinks in terms of resources. A patient is a resource. An appointment is a resource. A lab result is a resource. And just like web pages, they can all link to each other using standard web tech. It's so simple, and that's what makes it so powerful. So FHIR, that's FHIR, Fast Healthcare Interoperability Resources, is the modern standard. And it was built from the ground up for speed and ease of use. And that is exactly why it's being adopted so widely. We're talking major tech companies like Google and entire national health systems in places like the UK and India. It's a huge deal. Okay, listen up, because we're about to hit a concept that is absolutely critical for your exams, for sure. How do we get from this general idea, like a patient, to a very specific coded message about one particular patient's visit? This is where you have to understand two key models, the RIM and the RMIM. And honestly, the best way to get this is with an analogy. I want you to think of the RIM, the reference information model, as a giant dictionary, okay? It contains every possible concept you can think of in healthcare, but defined in a really abstract way. Now, the RMIM, the refined message information model, that's what happens when you pick specific words from that dictionary to write one single meaningful sentence for one specific purpose. So, sticking with our analogy, at the RIM level, the dictionary level, we're using these super general terms. An entity, like a person, can play a role like a patient, which then participates in an act, like a consultation. See how abstract and universal that is? It could apply to anything. But then, bam, at the RMIM level, our sentence level, we get super specific. That abstract act is now defined as a consultation. The entity playing the patient role isn't just anyone, it's a specific person, John Doe. We're using those universal building blocks from the RIM to construct a really precise message for one specific job. You know what? Let's try another analogy. Legos. Think of the RIM as your big box of Lego bricks. For example, you have a generic blue entity brick. It's a reusable block that could be a patient, a doctor, a hospital, anything. It's that universal piece you can use to build a million different things. The RMIM, on the other hand, is like the instruction manual for building one specific Lego set, say the Millennium Falcon. It tells you exactly how to take that blue entity brick and that red act brick and combine them in a very specific way to build an encounter message. It's a specific model for a single purpose, built from those universal RMIM pieces. See the difference? Okay, deep breath. Let's pull all of this together into a final summary. Seriously, if you're taking notes, this is the time. This is what you absolutely need to have locked in for your exam. Okay, let's do a rapid-fire review. First, that three-step process, storyboard, model, framework. Got it? Second, interoperability is all about creating a shared language, whether it's the old-school HL7 or the modern FHIR. Third, remember that FHIR is the new kid on the block, using web-based REST APIs and resources. And finally, and I'm going to say this one more time because it's so important for your exam, the RIM is the abstract, universal dictionary of Legos. The RMIM is the specific, implementable instruction manual for one single use case. If you can explain that difference, you're in great shape. And there you have it. That's our deep dive into designing these interoperable health systems. We've literally gone from a simple story that can save lives all the way down to the nitty-gritty technical models that make it all happen. So we've given you the blueprint. The only question left is, what amazing healthcare problem are you going to solve with it?